All right, so I'm gonna try this again because it worked the first time I did it, but it didn't do a great job of capturing my screen, which is kind of a problem because I need to kind of keep up with me. So we'll try this again. All right. So we've got the problem here. Now for assignment 14, I don't have all the information I need to answer it. So let me go back to that. Um, I'm good with Excel, so I'm good with manipulating data in Excel, but I don't know what data is is being used, like if this is your personal data or if it's something that your instructor gave you. But I can, I'm good with independent variable and dependent variable, all that. That's no problem. I just need more information to answer that. So I can answer this one. This is relatively straightforward, or at least it will be after I explain it. This will make sense to you. So the thing we're doing here, we have a bunch of test scores from Mrs. Johnson's class of 15 students. She took test scores. She's trying a new learning approach, and she took scores from three different times. So from fall, winter, and spring. Okay, so these are the same students taking tests. We don't know if the tests are the same or different, but they're taking these tests fall, winter, and spring, and so we're testing to see if there's a difference between those test scores from each individual student in fall, winter, and spring. So we need to choose the appropriate t-test, get the mean and the standard deviation, which is all relatively simple. So we'll go ahead and get started with that. I've got the data loaded up here, so I've already loaded up, so it's in the recent files. And we got it right here. So I have something going on my other screen, but we won't worry about that. Okay, so you've got all these data here. So you've got the fall, winter, and spring. And what's really important about this, the thing that is kind of most key about these data is that each student takes a test three different times. And we don't know if it's the same test or not. It would be nice if they told us that, but it doesn't really matter because we know that these three observations have to be related to each other in some way. And what I mean by that is when we're examining these, we have to compare, the fall exam to the winter exam for student one, and we need to compare the winter exam to the spring exam for student one, and fall to spring for student one. We have to compare all of these together because if we don't, the comparison isn't very meaningful, if that makes sense, right? Like we've got one student, we need to connect everything together for that student rather than comparing, the fall exam for student one to the winter exam for student two. That's not a meaningful comparison. It's a much more meaningful comparison to compare everything for student one, right? These data they all relate to each other in some way. And so that's going to determine the type of t-test we have, but let's do the descriptive statistics first. We can get a good look at it. So that mean and standard deviation fall into descriptive statistics. They're kind of standard descriptive statistics. So we're going to move our fall, winter, and spring over here. These are all meaningful data, so we want those all in here. We don't need student ID in there because we don't need an average of the student IDs. The student IDs don't actually tell us anything. They're just, it's like the students' names. We don't need an average of the students' names, right? So we've got our descriptive statistics here. So valid just shows that they're valid. There's numbers in all these rather than like words or anything like that. There's no missing observations, which you can see when you look at it. There's no data missing in here. None of the students were absent for the exams, which is good. If you have a really big data set that you can't look through manually, it's nice to know things like that. So we have the mean, right, the average for these three. So we have 54, 74, 93. So it's going up by 20 each time. The average keeps increasing. We have the standard deviation, which if you're not familiar with standard deviation or you're not comfortable with it, that is just the average the average difference that any individual observation is from the mean, right? So like in this case, any individual test score, you get your average, right? So it's 54 for this column. And then standard deviation just tells you how far apart any given observation is likely to be from that. So the higher the standard deviation, the more variable your data are. The lower the standard deviation, the more tightly clustered they are. So it's an important indicator. It tells us a lot about the data to know the mean and the standard deviation. And these things are important if you're calculating t-tests. So you need these. And then minimum and maximum are nice to look at. It's kind of interesting. You can see here like the minimum and maximum for these. So there's very little overlap between fall and winter. There's no overlap between winter and spring, and there's no overlap between fall and spring, and there's no overlap between winter and spring. So we would suspect just by looking at these and looking at how far the means are that we're going to have statistically significant differences between these three groups, right? So let's go ahead and do our t-test. So we could take this and copy it and put it in a Word file here. I was messing around earlier, so we're going to delete this. Paste it in here. Now you need to do APA formatting. I'm not super familiar with that, but as I understand it, it's just like, do that table 1, maybe a colon there, maybe not. You look up the rules for APA formatting. Again, I'm not familiar with it. I don't use it. Now, you were only asked in the question to give the mean and the standard deviation, so you can actually remove all the rest of these data. You can delete that, shift the cells up. You can delete this one. Again, shift the cells up. And then delete these dumb lines that are wildly unnecessary, but whatever. We'll not worry about it. The last time I tried messing with any of these, I kind of destroyed everything, made my data all weird. So anyway, we won't mess with those, but yeah, those lines are kind of unnecessary there. There's a way. No, of course not. Anyway, we'll not worry about it. You can format the table however you like, but this is how this looks. So that's a great answer to question 1. Right. So the 3 questions are, do all this. So that's a great answer for question 2 rather. So we've got the means and standard deviations. So we've got it in table 1. It's APA formatted except for those 2 kind of stray lines. Which we could, you could just leave in the range information. That would get rid of that issue with the lines. Or we can do the t-test results, right? So let's do this because this kind of helps you understand the statistics better. So we need to choose a t-test. We've got independent samples, paired samples, and 1 sample. Now we obviously don't have 1 sample because we've got 3 groups, right? So this is a sample, this is a sample, this is a sample. So we've sampled this group 3 times, so it can't be 1 sample, and it can't be independent samples because we have, student 1 has taken these 3 exams. Well, student 1 can't be independent of him or herself, right? So student 1 is the same person when they take the fall, the winter, and the spring. So these are not independent observations, right? They're linked by the fact that they were all performed by the same person. So it can't be an independent samples t-test, which means it needs to be a paired samples t-test, which makes perfect sense, right? We're going to pair up these samples because we want to look at how individual students are doing in each set of observations. And so the way you do a paired samples t-test is you set up your pairs. So we're going to set up fall and winter. So this is 1 pair, right? That's a good pair. We'll do fall and spring. That's another pair. And then for good measure, we'll do winter and spring. All right, so these are the 3 possibilities for pairing up. We've done all those. Now, the only thing that I'm not 100% sure about here is the hypothesis, and the reason being is that the question didn't tell us, whether the teacher wanted to see if there was just a difference between the scores when you pair up the observations, or if they wanted to see if the change that they made in the class made a difference, like if it raised the scores. You would assume it's a teacher, you would assume that they're trying to raise the scores, but we can't be 100% sure, so there is some judgment in here. The thing is, statistically, it doesn't make a difference. So this, it gives you the same result if you choose measure 1 does not equal measure 2, or you choose measure 1 is less than measure 2, it's the same result, right? It's just the you get an additional note on here. So I think, and the results are the same, right? If you compare them between these two, they're exactly the same. So I think this is sufficient. So just a little discussion of the results that you get here. So these are your pairs, right? You have fall, winter, fall, spring, winter, spring. Those are the 3 pairs that we set up. The t statistic here just tells you how to say it. So it just kind of tells you how unlikely the observation that you've seen is. Like it tells you how in this case it tells you how different the 2 groups are, right? So fall and winter, this highly negative t statistic, and -8 is a highly negative t statistic. It's if you look at the t-table distribution, it's very unlikely that you get a statistic that high by chance. So what it tells you is that there's a big difference between these 2 groups, and the positive or negative isn't really important here. Either a highly negative or highly positive result tells you that that there's a statistical significance, significant difference between the 2 groups. The degrees of freedom, DF here, it just relates to the number of observations, right? So you've got 15 students, so you have 15 observations in each group. The degrees of freedom is usually the number of observations minus 1, so that's why it's 14 here. And so you determine the p-value from knowing these 2, right? So what they used to do back in the day is look up tables. So you would go in the table for 14 degrees of freedom, look up the t statistic that you got, which is just calculated. You would calculate this manually, and then that will tell you what the p-value is. And in this case, the p-value is less than 0.001 for all 3 of these groups, which is to say that these 3 groups are all different. And what we know, if we switch over to this one, what we know is that the earlier test scores are lower than the later test scores in all 3 groups, because we set it up so it's earlier on this side, later on this side. Right? I set it up like that on purpose because it makes it more coherent to understand. Okay, so what we can see from this is that we have a statistically significant difference in these 3 groups. That means that whatever change Mrs. Johnson made in her class, it's working. It's raising these test scores in all 3 of these groups. Okay, and it's as time goes on, the test scores get higher and higher. So between fall and winter, the scores got higher. They're higher in winter than they are in fall. And between winter and spring, they got higher again. So they're higher in spring than they are in winter, right? So this is a statistically significant result. And this is important. So this is why we do statistics, to find out if what we did worked, if it's a meaningful result, and so we're not just like looking, so we're not just over here looking at all these data and trying to figure out, well, is this meaningful? Like you can see it by looking at these because they're far apart. But if your data were a lot closer, or if you had a lot more observations, it's a lot harder to tell. So this just gives us a way to, to kind of take the judgment out of it. The test decides for us if it's significant. So we can go ahead and copy this here, put it in our Word document. So I'm actually going to go back and, yeah, I like that better. Yeah, that looks nicer. It's nicer like that. So we're going to remove that. So what we have here, and again, you want to do it, I don't know anything about APA formatting, so you just want to make sure that it's right, but this would be table 1. If you're going to use this to answer the question, you use table 1. This is your paired samples t-test. So wait, I'm not going to save it. So you can leave this note in here or take it out. This just tells you if you were setting it up so the 2 groups are not equal, just to see if there was some difference between like fall and winter, for instance. And if you leave this in, it shows that you were testing to see if winter was higher than fall, if it was directional, if like the later test scores were higher than the earlier ones. All right, so you've got that all, that looks good. You could add some more information in here. you know, how you label it is up to you. Like that's you know what your teacher wants better than me, but that's how that all works. Oh, wait, is it not? Just a second here. What is this? Okay. There we go. Okay, sorry, I'm not. Sorry about that. So, you know, all I did was paste it in here and put it on this document. So I'm sorry if you couldn't see that all. I didn't realize my screencasting software was staying with the um, program rather than with the window. That's a little weird, but whatever. Um, so the other thing that we need to do then is make a let me see the question again. The other thing that we need to do is make a figure that displays the means for the 3 test times and label it figure 1. So I have an issue with this, and the issue is that, so we can go back to descriptive statistics. Let's remove all these. Go back to descriptive statistics. I'm going to add these back in because we want fall, winter, and spring. And you usually want to keep your data ordered meaningfully, so you want it to be fall, winter, and spring because that's, you know, the time order, the chronological order for it. So we can do plots here. So plots, just like that. And the type of plot we want is a box plot, is because that's the one that's going to show our mean, right? So this big dark bar is the mean here. I don't know if you can see my mouse even, but the big dark bar is the mean. And then it gives you the range as well as the quartiles here. So the issue with this is that the axis is different. So the spring one goes from 88 to 100, the winter one goes from 65 to 80, and the fall one goes from 30 to 70. So that doesn't really do me any good in terms of comparing them. Like that's no good. So you can. I'm not sure if that's what your professor's looking for or not. I don't. You know, usually when I'm making a figure, I want to compare things. So I would say if you're allowed to do this, just do it in Excel, right? So you just select all your data. You don't need to select student ID because that's not going to help us here. You go to Insert and then go to the chart you want is this one right here, Insert Statistic Chart. Do Box and Whisker. All right, now for APA formatting, I do know that you need no color, right? So you want, let's see this one, you want a black and white one, all right? So now do a chart title, so figure 1, this is scores. And again, I don't know if the capitals are bad with APA formatting. I just don't use it. So, you know, you can iron out that part. I know you know formatting well enough to handle that. So we need a legend. I want the legend to be on the bottom because I think that's a better place for it. We're going to just delete this one because that does nothing for us. Now, I don't like this x-axis either because it is... or y-axis rather. I don't like this y-axis because it goes up to 120 and you can't get a score of 120. So we want to format, select it again. We need to format the axis. And we're just going to set it up. So we're going to make the maximum 100, right? That makes it more meaningful. And we also don't have any observations that are below 30. So we can go ahead and if you're allowed to do this, I don't know how your professor feels about things like this, make the minimum 30, which makes everything, you know, it makes the area a lot nicer, and then we can just kind of shrink the chart down so there's not so much empty white space, right? So that's a good looking chart. We can copy it. Paste it in here. And then you need to go down and just paste it. So yeah, keep the source formatting. I don't know. Okay, no, just paste it as a picture. So that way you get it black and white. which is how it's supposed to be. Now you could not put this title here and put the title over it like we did. It'll kind of keep that formatting. But other than that, I think it looks good, and I have been going on for 20 minutes, and hopefully this one works, because last time it stopped showing my video very much. So we will see. I'm going to stop.